All right. We are winding down the semester. This week is week 13. Next week is week 14, and then finally week 15. Final week, the finals week rather, the week after week 15, it will be the final due date on anything, any late projects or redos or whatever. So I'll post an announcement about this. My plan is to lecture today, to lecture next week, week 14, and then to give you week 15 sort of as a catch-up date for those of you who are still working on some of the assignments. All right, so anyhow, let's look at what we're going to look at today. This is a little application I wrote that implements a very simplistic game. I can never remember how to change this. I've found it before. Again, I'm not a Windows user, I'm a Mac user, so forgive me for not knowing that off the top of my head. Properties, not settings. Right, I do not see that. Still do not see it. Space P. All right, it's not working. This wouldn't be a huge deal other than the fact that I cannot see very well. Right click on the top bar. The top bar, right clicking on it. Do not have that. I guess we'll just have to do with this. I hope you can see it well enough. All right. I've created a Java version of a very simple sort of kids game. And it's called the high-low game. And let me compile everything, make sure everything is still good. Compiles cleanly. And I'll show you the game and then I'll begin speaking about it. So if I type in Java, high-low GUI, I get this box. And in this game, this is a dice game. And in this game, you roll 2 dice. Standard dice values are 1 through 6. That means that the numbers, the total of the 2 dice, will be 2 through 12. Now, in this game, you have to make a prediction of what you're going to roll. You can predict that you're going to roll low, 7, or high. If you pick low, then you're predicting that the sum of the 2 die are going to be 2 through 6. If you pick 7, then it's going to be exactly 7. And if you pick high, you're predicting it's going to be 8 through 12. And your payoff depends on how much you bet, or it depends on which choice you make. For low and high, you get paid even odds, 1 to 1. So if I bet 1 point and I win 1 point. If I pick 4, for example, and I roll an 8, I would lose that point. But if I picked 4 and I would roll a 3, then I would win that point. Now 7, since 7 is less likely, so that's just one of the numbers, I get paid 4 to 1. Now, this is a little game, but it kind of shows you how really even the simplest gambling games are rigged against you. Because chances of rolling a 7 are 1 out of 6. Therefore, it should be paying you 6 to 1 if it was paying out correctly. It was paying it based on the odds, but it's only paying out 4 to 1. All right. Because there are 6 different combinations that add up to 7 out of the 36 possible combinations. Now there's 15 out of the 36 that could be high, and 15 out of the 36 that can be low. That is less than 1 to 1. It's less than a 50-50 chance. Therefore, it should be paying you. It should be paying you better than even money, but it's only paying you 1 to 1 if you win. So let's play a few rounds. Let's see how my prediction skills are today. I'm going to start out and pick 7. Notice I start out with 100 points. Oh, I rolled a 12. 6 and 6 is 12. 12 is high. Therefore, I lose. And I deduct the 1 point. I'll pick low. I won. So I'm back up to 100 points. Because I rolled, 5 and a 1, which adds up to 6. And 6 is part of the low range. And I can do this. Oh, I should have bet on 7. I lose the 1 point. I'll pick low. Win. Seven again. I'm going to pick 7. Oh, 6. I lost. Pick high. Yeah, I won. Lost. I want to get ahead of, I want to end up with more than 100 points. Ooh, I lost. Lost again. I'm going to keep playing 7. So I win. Yeah, there I finally won, and I won 4 points. Well, again, if I continue to play this because the odds are stacked against you, eventually you're going to lose. But it's kind of a fun game to play, especially like for little kids. All right, so let's look at this game. Remember what this looks like. In fact, I'm going to take, let's remember what this looks like. off to the side here. And we're gonna look at how this was developed. First of all, look at the files that we have. We have D1 through D6, which represents the faces of a die. D1 is a 1 dot, D2 is 2 dots, all the way through D6. All right. We have a class that represents one of the dice. I know it should be die, is singular, but I called it dice.java because die.java sounds too morbid. So I have my dice class because, again, if you look at the entities in this, what do you have? You have a game and you have dice that you roll. And then you have the GUI. So I have really three classes working here. I have the GUI, which is a physical representation, visual representation of the game. I have the high-low game, which is the logic of the game. And then finally, I have the dice class, which represents one of these dice. So let's look at these in turn. Let's start by looking at the dice class. Well, what property and methods do a dice have? Well, dice has one property we're interested in, and that's the face value. In other words, the value that's on top. What can we do to a dice? We can roll it. All right. And so there's a roll method that's going to return an int, the int being the value that we rolled. We have a get method to get the face value that simply returns the value that's on top without re-rolling it. And then finally, when the constructor executes, we roll it to give it an initial value. That's what we have for dice object. Face value, constructor that rolls it, int function that rolls it, returns the value that we get, taking a random number. This will give us a random number between 1 and 6 inclusive. And then finally, we can get the face value without having to roll it again. And that's useful. Notice we don't have a set method. It kind of would be bad to have a set method, right? Because then you could sort of stack the deck. It'd be like having loaded dice, right? You could randomly set the dice to be certain values, and you don't want to do that. You don't want even the possibility to do that in the game. So this dice could be used in this dice class could be used in any dice game that we come up with. So if I was going to create a Yahtzee game, I would still use the same dice class because dice in a Yahtzee's game work the same way they do in this high-low game. If I were playing Monopoly, the two dice there work the same as here. So this is a good reusable class that if we were a gaming company and we wrote Java games, we could use this dice class wherever we needed dice. We wouldn't have to rewrite it. Now, we also have a high-low game class, and this is a class that contains the rules. So this class has two dice, D1 and D2. Notice each dice object represents a single die. It doesn't represent a pair. We have to make two of them if we want a pair. That way, if we were playing Yahtzee, we could make 5 dice objects. All right. We have selecting a play method. We have no constructor. All we have is a play method and a couple methods at the end. The play method accepts the choice. The choice we're going to define as 0, 1, or 2. 0 means we pick low, 1 means we pick 7, and 2 means we picked high. And we have the amount of the bet that we bet. So if the arg choice is less than 0 or greater than 2, you know that that was an invalid option. Now we're going to build our GUI to only allow that, but remember, this could be called from multiple GUIs. And maybe whoever created the second GUI wasn't as diligent as me and didn't have that validation in the GUI. So when we play this game, we roll the 2 dice, get the sum, initialize the payoff to 0. Then if they pick low and it's less than 7, their payoff equals what they bet. Otherwise, the payoff is -1 times what they bet. In other words, they lose the amount that they bet. If they chose 1, then then if it does equal 7, then the payoff is 4 times what they bet. Otherwise, they lose what they bet. And finally, if they chose high and it's greater than 7, their payoff equals what they bet. Otherwise, the payoff equals -1. And this function then returns the payoff. So play accepts 2 arguments, 0, 1, or 2, and a dollar amount of the bet. It validates that the choice argument is valid, and it runs, and then it returns the value of the payoff, whether it be a positive number indicating it won or a negative value which indicates they lost. We then have in the game object get dice 1 value and get dice 2 value. We do that, we call the get value function because we want to get the value from the dice without rolling it again. Up here, we roll it. If we roll it when we got the value, then we would be rolling it again and it would change what the value was previously. And we don't want to change what the value was previously. We simply want to know what that value was. Okay. So that's all well and good. How do I write a unit test for this? Well, I could write a unit test a number of different ways. How can I test every possibility, though? Well, what I can do is I've created a dice test object. Let's think about what we want our dice to do. If I roll the dice, say 20 times, I expect there to be around 21s, 22s, 23s, 24s, 25s, 26s. That adds up to 120. Now, it's not going to be exactly like that because of just random factors. But that's what this dice object does. I set up 6 counters. I create a dice, and I actually roll the dice 10,000 times. Let's change it to 12,000 times. So I would expect 2,000 for each of them. I roll the dice and I check to see what the value is. Depending on the value, I increment the counter. So if I roll a 1, I increment the 1 counter. If I roll a 2, I increment the 2 counter, and so on. When I'm all done, I print out those counters. Now, how do I know that this passed the test? Well, it's not going to be exactly that each one of them has 2,000. But I'm going to look to see a couple things. I'm going to look to see if the distribution is approximately equal. All right. I'm then going to look to see if I run this test a bunch of times, does one number consistently show up higher than other numbers? All these could indicate I got a bug in my dice program. Now, I know there's this only, this code looks really good and it's logical, but prove it. And that's what we do with our test classes. So I'm going to go recompile everything. And I'm going to run Java price test. Again, I still have people that are not following the conventions for class names and variable names. If you don't know what those are, please ask. But it's almost the end of the semester. If you learn one thing, you should learn that from this class. So I run it and I forgot to save it. That doesn't add up to 12,000. I want to do that. Right around 20,000. The furthest away is 1966. That's 34 numbers off. Well, I guess 2051 is a higher difference. But they're all within that range. What if I run it again? I run it again. I was worried about one being consistently lower, but I run it enough times and one has the most occurrences. And we can really up this to do as many as we want. We could do this not just 12,000 times, but 1.2 million times. Hey, this is a computer, right? Does things fast. So we ran it, and roughly 200,000 for each one. Run it again. Again, we don't notice any pattern in one consistently being the largest or one consistently being the smallest. So yes, I verified that my dice works. So let's imagine we were a team. In a large organization, there could be 3 people working on this. All right. Let's say it was person A's job to create the dice object. Well, they just simply wouldn't turn it over to the other 2 members of the team without testing it first, right? So this is a way to test it. So I did a unit testing. Later on, we're going to do a system test where everything has to work together. So let's look at ILO game test. And this I can play 100 times. I can randomly pick 1, 2, or 3. I can bet $1, and I can see if that's right. So I already compiled it. Let me run it again. There's the 100 games. I picked high and I bet 1, so I lost. I picked low and rolled a 10, so I lost. I picked high and I rolled a 9. Again, remember 2 is for high, 1 is for 7, 0 is for low. Oh, here I picked 7 and it was that. So, and it was 10, so I lose. Here I picked high and it was 9, so I win. Here I picked 7 and it was a 3, so I lose. And we can verify that. 100 times isn't that many times that I could verify and look manually to make sure that these results make sense. All right, here I picked 7 and I rolled a 7 and I win, so I get a payoff of 1. The point is that each person in our hypothetical team can test out their stuff before they turn it over. The dice person does their work and turns it over to the game person. But before they do that, they test to make sure that the dice object is indeed producing random numbers and that there isn't some skewing for whatever reason. The game person can take that dice object and now they're pretty confident they're doing everything right. All right. And we can take that and run their own test to make sure that the game logic works. Finally, we're going to put it all together and we're going to code the GUI. This is kind of like where the system test rolls down. We're going to make sure that everything working together works. We verify that those 2 individual component work. Now we're going to verify that those, when they work together, work correctly. Now, when things don't work together, could be a number of problems. It could be that there's a problem with one of the classes or the other class, or it could be the way that the classes are communicating. So even if we've tested the individual classes with our unit tests, we're still going to do a system test to make sure that everything's working together and they're communicating correctly. You certainly improve your odds of things working good if you do unit tests, but it doesn't ensure it. So here we have all this stuff. We have our high-low GUI, extends for and implements action lister. Implements action lister means that this is going to have a event action perform that accepts an argument of action event. So we said that it implements that interface, and it does have that function. So it successfully implements that interface. Constructor, we set that to be true. We set on close to exit. We create a panel and a sub panel for choices. Let's run this to see what we're looking at. We take our button, and we associate this class or this object as the action listener for it. We add to panel P the number of points or the label for points. Points go here. Label for points. So that label gets initialized, and that is this panel here. We then add to the second panel, the P choice panel, a label for choice. Let's make a choice. The drop down and the button to play the game. We add that whole panel to that P1 or that first panel, P. So now P contains this and it contains the second panel. And again, we have them stacked vertically, and we'll see why in a minute. All right. We then create another panel for the dice. And this is how we do images. We create 2 labels for the dice, J labels. Sounds a little weird, but it's one of the easier ways to do images. And then we add the dice, which is where it's going to show up here. We add that layer to our P panel as well. We set the layout as new box layout, y-axis, that stacks those things vertically. You set the point label, which simply sets the label to say you have blank number of points and you fill in with the value of points. So initially, it said 100. This will get called every time the button is clicked to update it. So that's how we set it up. We have these two sub panels called P dice and P choice. We populate them with the information about the choices and the information about the dice. And we add that to the panel P, which we make the content pane for this frame. When we click the button, we grab the value from the option list. Now notice the option list is a combo box that gets its values from option string. So we start with 0 because it's an array. Make choice is option 0, the array. Low is 1, 7 is 2, and 3 is high. If you remember, we want to change this so that low is 0, 7 is 1, and high is 2. Well, we do that simply by subtracting 1. So if we leave it at make a choice, get an exception. What exception do we get? That 1 from the high-low game. That's one thing that I didn't test in my unit test, is testing for exceptions, and I should have done that. But we test for them here. We then assume the bet is 1. I could have created a text box for bet to make this game a little more versatile. I calculate the payoff based on the game play function. Notice that we created that game object up here when we initialize the page. So we call the play method on that game object and get the payoff. Payoff's either going to be greater than 0 or 0. If it's less than 0, it means we lost, and we set the label results to loss. Otherwise, we've won. And we add the points to the payoff, and we display that. Now comes the fun part. We want to display the images of the dice. The images from the dice are simply D followed by the value of the dice.jpg. Notice we have that in this folder. D followed by the value of the dice.jpg. That's why we needed that get dice value method without rolling the dice. We don't want to roll it again because we don't want to change the value. Then we do this and set the icon for those two labels, and that gives us the two dice images. Simple game, but it brings together a lot of different concepts, and it brings together the notion of unit testing and system testing. I should test again, all possibilities. And I should make sure that it works. That gives me the exception. This correctly tells me when I've won, what I've lost. I'm doing the system test by putting everything together and seeing if it still works. Notice that there's no dice object in the GUI. Why not? Well, because the dice are part of the game object. Let's imagine if we wanted to put a different GUI on top of this. All right. All we need to do is plug in that game object here and the appropriate methods, and we're good to go. All right. As I mentioned before, and I will post this, next week we will have a lecture, and the following week, week 15, is the last week of classes, will be a work day for you to catch up. The following week, finals week, everything is due, whether it be labs, remakes of labs, or whatever. Now, what are we going to talk about next week? Next week, we're going to talk a little bit about IDEs for Java. An IDE is an integrated development environment. It would be like doing code in Visual Studio, not Visual Studio Code for Java. We're not going to be using Visual Studio, though. We're going to be using NetBeans, right, which is one of the many IDEs that's available. And you'll see some of the advantages to that. One of the advantages to that is that we are going to create code that can be deployed on other machines. So I wrote this code. I can compile it and run it on this machine. How do I get it to another machine to install? Well, typically that involves creating a jar file, a Java archive file. And the person on the other end would need the Java runtime engine. They wouldn't need the Java development kit. Now, we could also do things like put this on a web page. I could create a web version of this where the GUI was handled through the web, through a web page, and submitted to a Java class and had it executed. That's the two basic ways of deploying an application. Either it's installed on a local machine or it lives out on the web and you access it through a browser. We'll touch on both of those methods next time. All right, that's all I had for today. If you have any questions, let me know. If not, we'll see you next week.